Hi everyone, my name is Amrita Naina from Sri Venkateshwara College of Engineering, Department of Electronics and Communication Engineering. Today we are going to discuss a topic from the subject microwave and antenna. The subject code of this subject microwave antenna is 18EC63. The topic we are going to discuss is the scattering matrix for H-plane T junction. Now let us discuss the topic. A H-plane T-junction is formed by attaching a simple waveguide to a rectangular waveguide which already has two ports, the arms of the rectangular waveguides, which make two ports, this and this, while the third port is also called the side arm. So this is called the side arm, and these are called the collinear arms. The H-plane T is also called the shunt T. The axis of the side arm is parallel to the magnetic field. This junction is called the H-plane T junction. This is also called as current junction as the magnetic field divides itself into arms. Now let us write the scattering matrix for the H-plane T junction. We know that the 3x3 matrix here we are using because we have 3 possible inputs and 3 possible outputs. So this is the S matrix. From the symmetry property Sij is equal to Sji, we can write S12 is equal to S21. We can write S32 is equal to S23, and because here scattering coefficients S13 and S23 are equal, as the junction is symmetrical in plane. That means when there is an electromagnetic wave given here, then it is equally distributed over the two arms. Therefore we can write S23 is equal to S13 and S13 is equal to S31. The port is perfectly matched, therefore we can also write that S33 is equal to 0. The S matrix can be written like this here. S11, S12, S13 remains the same. Here we are changing S21 as S1, S12 because of the symmetry property, and then we are keeping S22 the same. Then we are changing S23 as S13. Then here we are changing S31 as S13. We are changing S32 as S13 because we can from the previous side we know that S32 is equal to S23. We can write that S23 is equal to S13 also. From the unitary property S into S conjugate is equal to identity matrix, we can write this. Now from multiplying row 1 and column 1, that from this matrix the row 1 and column 1 so if we can write it as S11 into S11 conjugate plus S12 into S12 conjugate plus S13 into S13 conjugate is equal to 1. This is the equation 3. The same way we can write equation 4 with respect to the row 2 and column 2, that is row 2 and column 2. So from these equation 3 and 4 we can write the equation 5 and 6. So from equation 5 and 6, that is let us subtract the equation 6 from 5, we get this equation S11 square is equal to minus S22 square is equal to 0. From this we can write that S11 is equal to S22. Now replace this S11 S22 as S11 in the S matrix. Here it was S22 in the previous slide. Here it is S22, then we will change it as S11. Now let us determine the values of S11, S12 and S13 and find the scattering matrix or scattering coefficients. Now from row 3 apply the unity property, that is we get S13 into S13 conjugate plus S13 into S13 conjugate is equal to 1. Simplify this equation, we get the value of S13 as 1 by root 2. Now from equation 5 is this one. From this equation we can find out some important things, that is we substitute S13 is equal to 1 by root 2 in equation 5. We get this we get that S12 is equal to S11. Now again we know that S12 is equal to S11. We'll substitute it in this equation and get this equation. From this equation we can write the we get the answer as S11 is equal to 1 by 2. Now let us find out the value of S13. So for finding out the value of S13 we apply the 0 property in the first and third column. So the first and third column are this and this. So if we apply the 0 property for these two columns, we get the equation S11 into S13 conjugate plus S12 into S13 conjugate is equal to 0. Now take S13 common, we get S13 conjugate into S11 plus S12, and we can prove that so we can also say that S13 conjugate is not equal to 0 because we have a value for S13 here, that is 1 by root 2. So we can write that S11 plus S12 is equal to 0. So from this we can write that S11 is equal to minus S12. Therefore S11 is equal to 1 by 2, we already know that. Therefore minus S12 is equal to 1 by 2. Therefore S12 is equal to minus 1 by 2. Now substitute all these values in the S matrix, we get this matrix. So we know that B is equal